This recording will include section 2.1 functions. If the value of a variable y is determined by the value of another variable x, then y is a function of x. The phrase is a function of means is determined by. If there is more than one value for y corresponding to a particular x value, then y is not determined by x, and y is not a function of x. When discussing two related variables, we can identify one as the first variable and the other as the second variable, and consider the set of ordered pairs containing their corresponding values. If the set of ordered pairs satisfies the function definition, then we say that the second variable is the function of the first one. In each case, decide if A is a function of B, if B is a function of A, or neither. A is the price of an item, and B is the sales tax for an item. So we know that the sales tax of an item will depend on the price. So B will be a function of A. Second example, A is your friend's name in your cell phone, and B is your friend's cell phone number in your cell phone. So we know that your friend's name will have one cell phone number, and then also the cell phone number will belong to one of your friends. So in this case, A can be a function. A is a function of B, and B is also a function of A. The last example, A is the age of a person and B is the shoe size of a person. We can have a lot of different age with the same shoe size, and then the shoe size can belong to more than one age group. So this will be neither. These are not function of each other. A function is a rule that assigns each element in one set to a unique element in a second set. A function is a set of ordered pairs in which no two ordered pairs have the same first coordinate and different second coordinate. Let's determine if each of the following is a function. We have, these are our inputs or our domain. We call this a domain, our input. So we have Phoebe, Amy, and Katie. And our range is our output, which is their height, 5, 5, and 3, 11. Is this a function? Every single person belongs to only one height. So yes, this relation is a function. The second example, we have ordered pairs. So the domain will be 1, 7, 8. 7 is repeating, and then 2. And our range is 9, 7, 1, 6, and 4, which are the second variables or the output or the y values. Since 7 input goes with the 7 output, but also with the 6, that means this relation is not a function. Next example is representing by a linear equation. Y, we can express y in terms of x. If you rearrange this equation, we will get y equals negative 4 over 5x plus 4, where our domain is any real number, so negative infinity to positive infinity. And the range also has no restriction, negative infinity to positive infinity. Should have write parentheses. This relation is a function. The next example if we express, we usually put y on the other side equals x squared. Y is a function of x. This is our domain, also from negative infinity to positive infinity, but a range would start from 0 to infinity. Every x value or input will only have one y value, so this relation is a function. Third example, if I would like to express y, will be rearranging the equation will be plus minus square root of x plus x minus 2. Because of the plus minus, if I have one x value, if I have an input, I can have two output going with the same input. So this relation is not a function. And our domain will start from 2 to infinity. And the range is from negative infinity to positive infinity. The next example is a absolute value function, absolute value relation, and which means if I have x, we can have more than y inside. We learned how to graph absolute value, which is always positive. So this relation is not a function. And this time x is expressed in terms of the y. Our domain will be 0 to infinity. And our range will be from negative infinity to positive infinity. The last example, if I would like to express y in terms of x, making some algebraic rearrangement, y would equal cube root of 5 minus x squared. Every single input will only have one output, so this is a function relation where the domain is from negative infinity to positive infinity, and the range is also from negative infinity to positive infinity. Any set of ordered pairs is called a relation. A relation can be indicated by a verbal description, a graph, a formula or equation, or a table, but there is always an underlying set of ordered pairs. Not every relation is a function. A function is a special relation. We also have the theorem of the vertical line test. A graph is a graph of a function if and only if there is no vertical line that crosses the graph more than once. So if we look at some graphs, and if I start drawing vertical line, and it's only crossing my graph at one point, that means this graph represents a function. Draw vertical lines and crossing my graph more than once, then it's not a function. If line crosses it more than once, not a function. Again, this is not a function. The next graph is a function. And our last example is also a function. A domain of a relation is the set of all first coordinates of the ordered pairs. The range of a relation is the set of all second coordinates of an ordered pair. State the domain and the range of each relation in problem 2, which I already did while I was explaining if that relation were a function or not. A function defined by a set of ordered pairs can be named with letters. For example, a function f can be represented 2, 5, 3, 8. Since the function f pairs 2 with 5, we write f of 2 equals 5, which is read as the value of f at 2 is 5. We also have f of 3 equals 8. A function defined by an equation can also be named with a letter. we can use g of x, reach g of x as a symbol for the second coordinate when the first coordinate is x. The notation is called function notation. The x in the notation is called the dummy variable because the letter used is unimportant. Let's check what f of 3 represents in this specific relation. 3 is our input. And when 3 was our input, the output is 4. F of x equals 2. We will find x. We know that 2 is our output, so we're looking for the second coordinate. So this is going to be 2. Then our first coordinate or our input is -4. Let g of x equals f of x minus 7 and f of x equals 2x squared plus 3x. We will be finding a certain expressions. G of 2 represents plugging 2 for x in function g. So 5 times 2 minus 7 equals 10 minus 7 equals 3. G of a plus 2 means we will be plugging in a plus 2 in place of x in function g. And we simplify 5a plus 10 minus 7 equals 5a plus 3. F of 3 represents putting 3 for x in function f, and then, simplify it. 3 times 3. So we will have 3 times 3 is 9, 2 times 9, 3 times 3 is 9, which is 18 plus 9, which is 27. F of x plus h means we're plugging in x plus h in place of x in function f, and then we simplify. So x plus h squared is a square of a binomial sum. So hopefully you remember this from algebra. Distribute with the 2. And we will just keep simplifying. 2x squared plus 4xh plus 2h squared plus 2x plus 2h further equals. Make sure I have some room. 2x squared plus 4xh plus 2h squared plus 3x oops, I messed up here. It's supposed to be a 3. So let's fix that real quick. There's a 3 in front. 3x, 3h, 3x, 3h. And I accidentally write it twice, so I apologize. Let's just quickly erase this. There we go. Definition: average rate of change from x1 to x2 if f of x1, y1, and if x1, y1, and x2, y1 are two ordered pairs of a function. We define the average rate of change of the function as x varies from x1 to x2 as the change in y coordinates divided by the change in x coordinates. We learned this in an algebra class. This was represented the slope for a linear equation. Find the average rate of change f of x equals 2 minus x 3x squared from x1 equals 1, x2 equals 3. What does the result mean? So we will have to find f of 1, which is 2 minus 3 times 1 squared. So f of 1 will be -1. We also have to find f of 3, plugging 3 for x. 2 minus 3 times 3 squared. which will equal 2 minus 27 equals negative 25. So we have 2 points, 1 with the negative 1 and then 3 with the negative 25. So we use the formula negative 25 minus negative 1 over 3 minus 1 will give us negative 24 over 2, which is negative 12. So that is the average rate of change. The following table shows a taxable wage base used in determining Social Security taxes for years from 1937 to 2019. Use the information in the table to answer the following questions. So we will be referring to the table. What is the average rate of change in the taxable wage between from 1954 to 1974? So if we go back to our table, we can find out then in 1954, it was $3,600, and 1972, it was 132,000. So you can go back and look for the year. We had 1954, which is over here. And then 1974, which is over here. And then we can use 132,000 minus 3,600 over 1974 minus 1954. 9,600 over 20 equals 480. That would be the average rate of change between those years. Next, we would find the two different years, 1974, which was 132,000, and then 1977, it was 165,000. So again, we're just gonna calculate the average rate of change, 165,000 minus 132,000 over 1977 minus 1974. So that will be 3,300 over 3, which is 1,100. What is the average rate of change in the taxable wage base from 2016? So 2016, if you go back and look at the chart, it was 118,500, and in 2019, it was 132,900. Again, plugging in 132,900 minus 118,500 over 2019 minus 2016 equals 4,800. What do each of the value means? So these value means, or they show how much the taxable wage increased. How much the taxable wage increased per year during a set time period. We also learned about the difference quotient in a college algebra class, which is an expression of f of x plus h minus f of x over h. Note this is actually the slope of the line that goes through x comma x plus h comma f of x plus h and the x comma f of x. Find the difference quotient for each of the following and simplify. Ensure the expression is defined when h equals 0. So we start with the easier one. We're going to find, again, we're looking for the difference quotient. So we're going to plug in x plus h first. 3 times x plus h plus 5 minus 3x plus 5, or plus 5, I'm sorry, all over h. And then, of course, we're simplifying this expression. So we distribute with the 3x plus 3h plus 5 minus 3x minus 5 equal h. Simplifying, we will get 3h over h, which is just 3. So in a linear function, the average rate of change just became the slope, the 3. Now, when the function is not linear, that's when it gets a little more complicated. That is a section where is different than an algebra class. So we're going to plug in x plus h first in place of x minus f of x, which is radical x plus 2 all over h. And this time we say we learned rationalizing the denominator before in a intermediate algebra and college algebra class. This time we are rationalizing the numerator, multiplying the numerator and the denominator with the conjugate of the denominator. That is the new calculus concept, utilizing the a plus b minus times a minus b equals a squared minus b squared algebraic rule. So the numerator multiplied in the conjugate, the square of the first term, which is x plus h plus 2, minus the square of the second term, which becomes the square root disappears. And then in the denominator, we will have h times x plus h plus 2 times x plus 2 square root. Simplifying the numerator, breaking up the parenthesis, x minus x will cancel out, 2 minus 2 will cancel out. So we will have an h over h times x plus h plus 2 radical plus square root of x plus h. And after h and h can cancel out, our answer will be x plus h plus 2. This is a technique that we use in a calculus class. That's why it is shown here. Making a little more room. Lastly, again, this is a more challenging one where we have to plug in x plus h in place of x all over h. So we'll continue in the next page. So the common denominator will be 2x times x plus h. So we have the first part will be multiplied with the x, and the second part will be multiplied with the x plus h, x plus h. Hopefully in a pre-calculus class, you know how to find the common denominator. So this will become x minus x plus h. Again, if you break the all over h, if we distribute with the negative, x minus x becomes a negative h over 2xx plus h. This means dividing by h, or is equivalent with multiplying with the reciprocal, which is 1 over h. So therefore, our final answer will be negative 1 over 2x x plus h. H and the h cancels out. And this is the end of section 2.1.